When you exercise, your body's demand for energy increases significantly, and as a result, the rate of respiration in your cells also increases. Respiration is the process by which your cells convert glucose and oxygen into energy, water, and carbon dioxide. During physical activity, your muscles require more energy to contract and sustain movement, which means that your cells must produce more ATP, the energy currency of the cell. To meet this increased energy demand, your body responds by increasing your breathing rate and heart rate, which helps to deliver more oxygen to your muscles and remove carbon dioxide more quickly. Aerobic respiration, which relies on a plentiful supply of oxygen, becomes the primary method for generating the necessary energy during moderate exercise. However, when you engage in intense or prolonged exercise, your muscles may demand energy faster than your body can supply oxygen. In such cases, your cells switch to anaerobic respiration, a process that does not require oxygen but produces much less energy compared to aerobic respiration. The byproduct of anaerobic respiration in muscles is lactic acid, which can accumulate and lead to muscle fatigue and soreness. This process allows your muscles to continue functioning for a short period even when oxygen levels are insufficient, but it is not sustainable over long periods due to the limited amount of energy produced and the buildup of lactic acid. The accumulation of lactic acid during anaerobic respiration creates what is known as an oxygen debt. After you stop exercising, your body needs to repay this oxygen debt by removing the lactic acid from your muscles and converting it back into less harmful substances. To do this, your body continues to consume oxygen at an elevated rate even after exercise has ended. This is why you may continue to breathe heavily for a while after finishing a workout. The extra oxygen taken in helps to break down the lactic acid, replenish the body's energy stores, and restore your muscles to their normal state. The oxygen debt is essentially the amount of oxygen required to bring your body back to its resting state after intense exercise. Investigating the effect of exercise on the body can be done through various experiments that measure different physiological responses to physical activity. One common method is to monitor heart rate, breathing rate, and the level of oxygen consumption before, during, and after exercise. For example, you can measure your pulse rate before starting an exercise, such as running or cycling, and then measure it again immediately after stopping. You can continue to measure your pulse rate at regular intervals as you recover, noting how quickly it returns to its resting level. Similarly, breathing rate can be measured by counting the number of breaths taken per minute before, during, and after exercise. These measurements provide insights into how the body responds to the increased demand for energy during exercise and how effectively it can recover afterward. Other ways to investigate the effect of exercise include measuring lactic acid levels in the blood, monitoring changes in body temperature, or using spirometry to assess lung function and the efficiency of oxygen uptake. These investigations help to illustrate the body's remarkable ability to adapt to the stresses of exercise, as well as the importance of aerobic and anaerobic respiration in meeting the energy demands of physical activity. Through such studies, we gain a better understanding of how to optimize exercise routines for health and performance, how to prevent injuries, and how to manage conditions like oxygen debt effectively.